In computer science, data structures are ways to store and organize data so it can be used efficiently. Knowing about data structures is important because picking the right one can dramatically affect the performance of a program. Let's look at two of the simplest data structures, stacks and queues. First, stacks. The word stack in computer science is used a lot like it is in English, so let's think of a stack of books. If you want to add a book to the stack, you'll add it to the top. And if you want to get a book from the stack, you'll start from the top as well and remove elements. It's cumbersome to access a book in the middle of the stack, so we generally avoid that. A stack has a top and a bottom, and we can add and remove only from the top. In computer science, we tend to talk about pushing elements onto the top of a stack for adding, and popping elements from the top of a stack for removing. So a stack is a data structure in which elements are sorted by insertion order. The last element that you put in is the first one that's going to come out. Elements have no index, so we can't access them in the middle of the stack. We can only add to the top and remove from the top, pushing and popping. Stacks are useful in contexts in which we want to reverse the order of elements. For example, think about the undo button in a lot of applications. The application stores activities performed in a stack. And so when you press the undo button, the activity that's undone is the last one that was performed. Now let's look at queues. The word queue is not used in American English very often, but in British English it means the single file line. So let's think about a line at a movie theater. So somebody starts the line and additional people may join after the first person. And the first person to get help will be the first person who joined the line. So queues have a front and a back. And we can add elements to a queue only from the back, and we can remove elements only from the front. In computer science, we might talk about adding as enqueuing and removing as dequeuing. Just like in stacks, elements in queues don't have indexes, so we can't access them directly. Again, think about the movie theater line example. The person working at the theater can't just ask the person in the red shirt to come and be helped. The patrons get helped in order. So a queue is a data structure in which, just like stacks, elements are sorted by insertion order. However, in queues, the first element that you put in is the first one that comes out. Again, elements have no indexes, so we can't access an element in the middle of a queue. We can only add to the back and remove from the front. Queues are useful in contexts when we're managing resources. For example, think of a print queue. If we have many people in an office sending jobs to the same printer, the first person who sends a job to the printer gets their job first. Similarly, if we have a website and several people are accessing that website, the first person who tries to access it is the first person who gets the page back.